Hi Rob.
Hello.
How you doing?
Yeah, pretty good, thanks.
So we're sat inside a vehicle that's kitted out with a lot of high-tech stuff.
Yeah, so this is our mobile workstation that we use for controlling ADAS and automated driving tests out on the proving ground. It's got lots of equipment in here that allows us to firstly monitor vehicles that are under test, but then also robotically control vehicles that we're using as part of automated driving tests.
Okay, so looking at things like ADAS, clearly there's a lot of vehicles now on the market that use that type of equipment, things like emergency braking, things like adaptive cruise control, lane keep. How do we actually encompass those tests and others from this vehicle?
So those type of features that you mentioned are typical ADAS features, low levels of autonomy. We look to test both those features and also try to combine features together to reach vehicles that have got much higher levels of automation. All of those tests can be controlled from this vehicle, and the type of tests that are typically performed are quite wide-ranging. They use a large number of different facilities out on the proving ground, and being able to repeatedly complete those tests in a consistent manner is very, very important. So in order to do that, we need to use equipment like this to make sure that the tests are completed in the same way over and over again.
Okay, and when we're doing those kind of tests, there's also other kit that we put out in the proving ground as well?
Yeah, so there's two other ways that the test vehicle is maybe interacting with other things. The first is that it can interact with physical actors in the scene. That could be either robotically controlled other vehicles, it could be robotic platforms running with soft targets on top of them, replicating full vehicles. It could be vulnerable road user targets like childs, adults, pedestrians and cyclists. It could also be that the vehicle is interacting with other actors that aren't actually physically present. They're in a simulation environment, and the vehicle is communicating through a platform with targets that are present only in the simulation environment, and it reacts to those. And we can control all of those tests using this vehicle.
Okay, and so that cuts down a lot of issues or likelihood that we could have with accidents actually occurring.
Potentially yes, but more importantly it helps us to develop what we're referring to as a CAV test ecosystem, where we're pulling together lots of different types of testing. That combination between physical test and simulated test is very important, a very, very crucial part of the development of that ecosystem.
Okay, and we've got LCV coming up. You're going to be presenting on our booth there?
Yep, so I'll be talking about the CAV test ecosystem, what we're trying to implement here at MIRA, both in the physical world and the simulated world, and also taking the tests that we do here on site out onto the public road and looking at that part of the validation challenge and how those all come together to deliver a fully validated automated vehicle solution. We'll also have the van here on the stand, so you'll be able to come and take a look, and we can talk around some of the equipment that's here and how we use it to perform tests.
Great, and if people wanted to know more information about the offering that we have?
Best way is to get in touch. We're always happy to have conversations around our capabilities, what we're able to do, so either go through the website or make direct contact with us here.
Okay, that's great Rob, thanks very much.
No problem, thanks.